In this tutorial, you will learn to create a full-stack web application from scratch using PostgreSQL for the database, .NET Core Web API for the backend, and Vue Js for the front end. We will first start with creating the necessary database objects in PostgreSQL, then create the Web API project with the required REST API endpoints. Finally, we will use Vue Js for creating the front end. You will learn how to add routing for our app. Create Bootstrap table with custom sorting and filtering capabilities. Add Modal pop-up windows with drop-downs and date pickers. We will also learn how to upload an image and store it in the backend server. Welcome to the course and happy learning. Let's install Visual Studio. You can choose to install the community version, which is free to download and use for educational purposes. Run the installer file. I have already installed Visual Studio, but if you are installing for the first time, you will be presented with this screen. You can choose ASP.NET and Web Development, .NET Desktop Development, and .NET Cross-Platform Development and click on Install button, which appears in bottom right. The installation will take quite some time as the IDE is big. Let's install Visual Studio Code. Visual Studio Code is a popular lightweight code editor from Microsoft. It is mostly used for front-end web development. Let's install Postman. We will be using Postman to test our REST APIs. Let's install pgadmin, which we will be using to connect to PostgreSQL and create the necessary database objects. We are required to set a master password the first time we log in. Let's open pgadmin and start creating the necessary tables in the database. I have already procured a Postgre server from Azure. I will be connecting to the same. Let's first create a database. We need two tables for our app. One to store department details and another one to store employee details. Let's start with department table. It will have two fields. One to store an auto-incremented department ID and another one to store the department name. Let's insert some records into it using insert query. Let's check the data using select query. Now let's create the employee table. It will have 5 fields: employee ID, employee name, department, date of joining, which is a date field, and finally photo file name, which stores the uploaded profile picture file name. Let's insert a record. And check data using select query. We have successfully created the database objects needed for our app. Let's create the .NET Core Web API project. Let's open up Visual Studio first. Click on Create a new project. Choose ASP.NET Web API Core. Choose appropriate folder. We might not need HTTPS for now. Now let's take a look at some of the important files. All the dependencies and packages needed for our app can be found in the Dependencies folder. Launch settings.json file contains the details of how the project should be started. Controllers folders contains controllers in which we write our API methods. We generally keep the configuration details such as database details in app settings.json. The program.cs contains the main program, which is the entry point of our app. Also, it creates webhost, which basically helps the app to listen to HTTP requests. The startup class configures all the services needed for our app. Services are basically reusable components that can be used across our app using dependency injection. It also contains the configure method, which creates our app's request processing pipeline. We need to make a couple of changes in startup class. One is to enable the cores. By default, all Web API projects come with a security which blocks requests coming from different domains. We are basically writing instructions to disable that security and allow the requests to be served. We are also making one more change to the serializer class to keep the JSON serializer as our default. We might need to install a NuGet package to do this. Let's import the namespace. Now let's simply run the project and check if everything works fine. We see that the project works as expected, and we see the JSON result from one of the sample controller method. Now let's create the models needed for our app. Let's create a folder to add our models. Let's add the department model. Department model has two fields: department ID and department name. Next, let's add the employee model. It has 5 fields: employee ID, employee name, department, date of joining, and photo file name. Let's start creating the API methods. Let me first add the PostgreSQL database connection string in app settings JSON file. To work with PostgreSQL, we need to install a NuGet package called npg-sql. Now let's add an empty controller to write our API methods for department details screen. To read the connection strings from app settings file, we need to make use of dependency injection. Now let's write an API method to get all data from department table. I am writing raw queries here. You can choose to write stored procedures or maybe use Entity Framework for this. I will be getting the data into a data table object. We can make use of SQL Data Reader to populate the data into data table object. Using the given SQL connection and SQL command, we will execute our query. And fill the data into data table using SQL Data Reader. Finally, we will return this data in JSON format. Let's test this API method. This seems to work. Let's now add the post method to insert new record into department table. We will be sending the department object to our post method in the form body. Let's also create the put method to update records. And finally, let's implement the delete method. We need to make some changes to the attribute so as to accept the ID and URL. Now let's test our API methods. Let's add a department using post method. We see that the record is added successfully. Let's verify this using get method. Now let's use the put method to update a record. The put method also works as expected. Now let's check the delete method. We see that the delete method also works as expected. Let's implement the API methods for employee details screen. Let's add an empty API controller. Let's copy the contents from department controller and make changes accordingly. Now let's test our APIs. The get method works fine. Let's test the post method to insert a record. Post method works fine as expected. Now let's test the put method and update a record. And finally let's test the delete method. The delete method also works as expected. Let's now write an API to upload the photos. Let's create a folder to store photos. To be able to use this folder to store and retrieve photos, we need to add some instructions in the startup class. Now let's write the API method. I am giving a custom root name for this method, and this is a post method. If there is any exception while saving file, I will simply return the default anonymous picture file name. We are going to extract the first file which is attached to form data. We need to again use the dependency injection to get the application path to Photos folder. Once the file is saved, we will simply return the file name. Let's now test the API by uploading an image file. We see that the upload was successful and we can see the image in the newly created path. Let's now create the Vue Js project. Navigate to the folder where we need the project and open Visual Studio Code. Let's create an index.html file. Let's add Bootstrap for styling our app. The styling reference goes in the head section of our HTML. And the bundle JavaScript reference can be added at the closing body tag. We will be using the CDN version of Vue Js for our front-end project. So let me add the JavaScript reference for Vue Js and Vue Router JS files. Vue Router is needed to add the routing capability for our app. We also need to save the API URL somewhere in our front end. So let's create a variable.js file and save the URLs in it. Let's also reference the variables.js file in index.html. We also need to include Axios library, which will be used to consume the API methods. Let's add the routing and navigation to our app. Let's first add a div tag with ID as app and add some headers. Let's see how it looks by opening the HTML file. Now let's add the components or the pages needed for our app. We will add 3 screens. One for home, one for department, and one for employee. We also need a root component inside which we will list the routing paths. Let's add it with name app.js. Let's add a simple template for each of these screens. The HTML is written inside 2 backticks. Let's add the routing paths. /home will be given for home component. And /employee for employee component. /department for department component. Let's create a Vue router object and pass the routes array. Now let's create a Vue object. This will be mounted to the element with ID app. This is the same ID that we used for our div. Now let's add the navigation menu. Router link is the tag that will help with routing. Let's check if this works. We need to add one more tag called routerView to make this work. Let's add class container to our div. Looks like we have not referenced the JS files. Let's do it. We have not changed the component constant names in JS files. We see that the routing and navigation works as expected. Let's consume the get method and display the data in a grid. Inside data, we can declare all the variables that we can use inside the template. I am declaring an empty array which will be populated using the getAPI method. In the methods section, let's write a method to consume the getAPI method. We are making use of Axios to consume the API methods. Once the response is received, we will assign the data to the departments array. There is a lifecycle method called mounted which will be called when this component is in scope. We will call the refresh method here. Now let's add the bootstrap table to display our data. We will loop through the department arrays using v for directive. In the options column, we will add two buttons. One to edit the record, and another one to delete a record. Let's add bootstrap icons inside these buttons. Let's check how it looks. Looks like we missed a closing t-head tag. The grid seems to look fine now. Let's add the Modal pop-up window to add and edit the department. Let's add the modal title from variable since we will be using same modal for adding and editing. Let's define the modal title variable. Also, we need form fields department name and department ID inside the modal. Let's add the text box for department name. The vModal directive gives us two-way binding, so the value entered in the text box will be available in the department name variable. Let's add two buttons, one to create new department, another one to update the department. The Create button will be visible when department ID is set to 0. Now let's add the button to open the modal window. This button will be to add new department. Same functionality on click of edit department. On Add click, we will set the title to Add Department and Department ID to 0. And on Edit click, we set the title to Edit Department. We see that Modal window works as expected. Now let's add functionality to create and update departments using the API URLs. Once response is available, we display the message in alert box and also refresh the grid. Let's test the functionality. We see that the create and update functionalities work as expected. Now let's complete the delete method. We will pass the department ID to the delete function. We will take the confirmation before calling the delete API. We see that delete also works as expected. Let's complete employee details screen. We will copy the contents from department screen and make changes accordingly. The Modal window will now have more form fields and image to be displayed. So let's use Bootstrap Flex. Department field will be a drop-down. The option values will come from departments array. Date of joining will be a date field. Now let's add a div to display profile picture. The image source will come from variables. Let's also add upload button for uploading new images. The photo path is already defined in variables.js file. We will use the same. In refresh data method, we will refresh both employee and departments array. Let's now add method to upload the image. We will attach the first file to form data. Once upload is successful, we will replace the photo file name variable. We see that the screen is now displaying data. Let's check the create and update functionalities. Finally, let's test the delete method. We see that all the functionalities in employee screen work as expected. Let's implement sorting and filter feature. Let's do it for departments table. Let's start with filtering. We need text box to enter the filter text. We will be using department ID filter variable to store the filter text. We will execute the filter function each time new letter is entered. Let's add a filter text box for department name column as well. Along with filter variables, we also add one more array which will store backup data without any filters. Now let's implement the filter function. We will be using includes method to check if the filter text matches with the array data. Let's check the functionality. We see that filtering works as expected. Now let's implement sorting feature. We will add two buttons for sorting. One to sort in ascending, and another one to sort data in descending. If we pass true, it means we need to sort it by ascending. Let's add icons for the filter buttons. Now let's implement the sorting function. Let's check the result. Looks like we made an error while passing parameters. We see that the sorting works fine now.